Hi there, 8th grade students. It's Mr. Pouts with your lesson 2.7, and this section is all about solving proportions. We're going to learn about what proportions are and how we can solve them a couple different ways. Make sure before you do anything, please make sure you write down your goal, which is to solve and apply proportions right on your goal sheet right now so that you don't forget later. On your goal sheet, all right? And afterwards, you need to self-assess yourself. So if you need to stop what you're doing, open up the goal sheet and write it down. Okay, in solving proportions, we need to know what a proportion is. So here's what we got. A proportion, you've done proportions before. But a proportion simply is an equation that states that two ratios are equal. For instance, remember it has to be an equation, so an equation must have an equal sign. So an example here that you might want to write down to help you picture it would be 1/2 equals 2 over 4. It's 1 over 2 is equal to 2 over 4. Those are two ratios, and they're set equal. So that's a proportion. Typically, we'll see something along the lines of 1 over 2 is equal to x over 4, and you need to solve for x. So that is also a proportion, and we're going to show you a couple different ways to solve for x in that situation. Okay, that's what a proportion is. All right, there are two different ways that I'm going to teach you to solve proportions. Okay, you can solve a proportion two different ways. You can solve like a one-step equation, which I'll show you works sometimes. It does not work all the time. And then the cross products, which you're probably familiar with too, those always work. So we're going to do cross products a lot more than the one-step equation process. But for this first example, I want to show you both ways. So here's the example. It says solve the following proportion for m. So we have 7 over 8 equals m over 12. Thinking about this, I don't know if I like this example anymore. But we'll use it, I guess. Okay, 7 over 8 equals m over 12. How will we change that to m over... Well, we'll leave it as 12. Okay, m over 12. We're trying to solve for m. So, first... So the first way I want to show you is the method of solving like a one-step equation. If you look at this as not even realize caring about what is on the, I'll even cover this up for you. Not even caring about what is on the left side. You have m over 12 is on the right side, and we want to try to, step one, isolate m. So if this is division, it says to isolate it by using multiplication. So we're going to multiply by 12. So then on the other side, I'll uncover this so we can do this now. But then we can multiply by 12 over here. Oops. And when you multiply by 12 or 12 over 1, those cancel out. You're left with just m over here. And then you just have to figure out what 12 over 1 times 7 over 8 is. You do end up getting, I believe, 84 over 8, which would then simplify to 10.5. All right, so it'll be 10.5. M is equal to 10.5. You can check that by plugging it back in and then simplifying. So if you divide 7 over 8 and 10.5 over 12, they should be equal to each other. Okay, that's the one way. It only works if it's a situation like this where you actually have the variable on the top. So now I want to show you the other way. Make sure you have both methods written down though. I want to show you the other way, which we'll use most often. That's called cross products, and this is probably what you're also familiar with. So cross products method, it says to multiply each pair of diagonal numbers. So we have diagonally 8m, and we have 7, 12. So we're going to do 7 times 12. Well, we'll do the 8 and the m over here. 8 times m, 7 times 12. Okay? Let me actually get rid of this so I can extend this page a little bit. Then it says set those products equal to each other. So those are actually going to be equal. The cross products property says that cross products of a proportion are equal. So this would be 8m equals 70, 7 times 12 is 84. Okay, so 8m equals 84. Then step 3 says solve for m using proper inverse operations. In this case, you just have one thing to solve. You divide both sides by 8. That's where a lot of people forget that you actually have to do one more step to solve for m after you do the cross products. It's 8m equals 84. So then divide both sides by 8 and you get 10.5. Okay, so m equals 10.5, just like we got before, just a little bit different. Now it does say then to check your solution by plugging it back into the equation or into the proportion. You can trust me on this one, it will work out. The cross products property is the one that I would like you to use most often because it'll always work. So we're going to practice it with a couple more examples here. I would for sure have you try number 2 because that's one of the more challenging ones. Number 1 though we'll do real quick. We're going to use that cross products property again. Hopefully you wrote down the steps if you don't remember it on your own. Multiply each pair of diagonal numbers. So we're going to do 3 times 8 and 4 times x. We'll do 4 times x over on the left side. And we're going to, and step 2 says to set them equal to each other. So 3 times 8, set them equal to each other. So it would be our first one, second one. We're going to solve it. We're going to simplify this as 4x equals 24. So we have to do the inverse operations then to solve for x. Should just be dividing by 4 on both sides. So x is equal to 24 divided by 4, I believe, is 6. If you would plug it in, those would be equivalent fractions. Okay. Now we're going to do the same process with number 2. And again, if you're looking at this, if you open up these smart slides from Moodle, you can look at the work by pulling that tab. I'm just going to work through it with you right now, though. So we're still going to do the cross products. We're still going to, I'm going to put parentheses around these now just because we're going to need them. We are going to do the cross product of this one and the cross product of this one. I think that was a 5. Let me, that's totally 5. Okay, so we're going to do this one right here first. So it'll be 5. We're going to multiply it by the top one, which is the other diagonal, which is b plus 3. So multiplying, you just show it like that right now. We can't do it in our head. We don't want to do it in our head. That's when mistakes happen. Set that equal to the other cross product, which would be, now I have to erase this so you can tell. I think for this one, I'm just going to draw lines. So that to that, and that to that. So then we do 4 times b minus 8. All right. Now if you look at it, this is just, it turned into a multi-step equation with variables on both sides. So we have to follow the same steps, which it's right here, solve for m using proper inverse operations. So first we're going to check for any distributing or combining like terms, and you might see already there is distributing. So we're going to do this and this on each side. So the 5 times the b is 5b, the 5 times the 3 is 15. Right side, 4 times b is 4b, minus sign, 4 times 8 is 32. Okay, there's no like terms on the two sides, either side that we could do. So now we're going to try and get the variable to the same side. Always move the variable term first. So we'll do that by subtracting whichever one. We can subtract it from one side. And I always go with the smaller one. So we're going to subtract the 4b here. So that cancels out, and we'll subtract the 4b over here. Remember, we have our two sides of our wall here. That leaves us with 1b, or simply just b, plus 15 equals, remember, this should be a plus a negative 32, so it is a negative 32 over here. All right, and last step to solving for this would be to subtract 15 from both sides. Because b is then by itself, there's no coefficient in front of the b. And we can do negative 32 minus 15. They're both negatives, so it's going to be a bigger negative. That'll be negative 47. All right. Now, you really should plug it back in there to check. For right now, well, we do that. So let's do negative 47 minus 8 will be negative 56. or yeah, no, 55 over 5. That would be equal to negative 47 plus 2 would be negative 44 over 4. And both sides are going to be equal to negative 11. This is our checking here. And that makes us happy. So B really is negative 47 for this one. Okay, there will be some where there are multi-steps like this, where you have to still do the cross multiplying. It just turns into some distributing and solving for B. I have one more example I want to go through. Hopefully these will help you out. This one is a word problem, very common type of word problem that you can use proportions for. So remember, proportions, you want to look for things that would be equal and then having the same types of things on both the top and the bottom of the ratio. So this says, in a shipment of 400 parts, so remember 400 parts, that will circle that because that's a good number, 14 are defective. How many defective parts should be expected in a shipment of 1,000? So I'm going to write it out. We're going to do 400 parts and over 14 are defective. That's our ratio. Now I'm going to set that equal to, and since we still have the second one, would be we're going to get 1,000 parts. And we want to know how many defective. So we're assuming the ratio would be constant or consistent, the same. So over, we'll say X defective. And we want to solve for X. Okay, so setting up the portion might be the hardest part, but you can see here the top has the parts, bottom has the defective ones. Got to keep it consistent in both ratios so that, like, if you have parts over defective on the left side, it should be parts over defective on the right side. Then we're going to do our cross multiplying. So we've got 400 times X. Set that equal to 14 times 1,000, which would be 14,000. The only thing to solve for X would be divide both sides by 400. And we'll get what X is equal to. I'm going to use my calculator to check this because I don't know this by heart or just off the top of my head. I could take a guess. It would be pretty close. I bet you it's 3.5, but I know that wouldn't make sense. 300, 3,500, that's my guess. I don't know if that's correct. All right, anyway, so we divide both sides. Let's do 14. Yeah, I'm divided by 400. It says 35. Yes, so if X is 35. That means that if 1,000 parts were ordered, about 35 of them would be defective. So how many defective parts? I'll say 35 defective parts. Sorry, I was doing really bad math in my head. That's why I use a calculator. All right, so that makes sense. Kind of as you get more parts, more will be defective. That's just how it goes. Okay, so this is our work with proportions. I hope you took quality notes. You had at least 1 or 2 examples written down, the vocab written down, and now it's time to self-assess your learning. So don't forget to self-assess. On the goal sheet, always. But that's all we have for today. We'll talk to you next time.